interest. So let's begin. Let's declare three variables: a principal, a rate, that is rate of interest, and time. Time will be in years. We've recently learned about while loops. I would like to include those within this program, just so we get the hang of using them. We will ask the user to type in an initial principal investment. We will continue to prompt the user to type in a principal that's above 0. Our condition will be while principal is less than or equal to 0. We will take our principal, assign it some user input, enter the principal amount. Then we would like to typecast our input as a floating point number. If our user input, principal, is less than or equal to 0, we need to inform the user. Principal can't be less than or equal to 0. So I'm going to test my program by printing the principal at the end, just temporarily. Enter the principal amount. I can't type a negative number and continue. What if my investment was negative $1,000? Principal can't be less than or equal to 0. How about 0? Nope, can't do that either. Is 1,000 okay? Yep, 1,000 works. That is for the principal. Let's copy this while loop, paste it, replace principal with rate. This is the rate of interest. Enter the interest rate. Interest rate can't be less than or equal to 0. And let's copy this again, paste it, change rate to time. Let's typecast our input as an integer because we're working with whole years. Enter the time in years. Time can't be less than or equal to 0. I'm going to print my principal, rate, and time. We have principal, rate, time. Okay, we know that principal works. Enter the interest rate. Can my interest rate be -1? No, it can't. Can it be 0? Nope. How about 10%? All right, that works. Time, can time be 0? No, it can't. Can my time be -1? No, it can't. What about 3 years? All right, so we know that our while loops are working. Now here's the formula to calculate interest. Let's say our total, that's our total balance, equals our principal times 1 plus our rate divided by 100. I'm going to enclose this function with a set of parentheses. This portion of our function will take our interest rate, which is a whole number, then create a decimal. Enclose this function within the power function. Raise this function to the power of time. And that is how to calculate compound interest. Then we will print the new balance. I'll use an F string. Balance after our variable time, the word years. I'll add a placeholder. We will add our total. Then I'll include a $sign. Maybe this will be in dollars, but pick any unit of currency you would like. I will format this variable with the format specifier. We will display 2 decimal places, point to F. Okay, let's try this. Enter the principal amount. I invest $1,000 into maybe the stock market. The interest rate is maybe 10% this year. The time in years will be 1. So after 1 year at 10% interest, my new balance is $1,100. Let's try it one more time for good measure. Maybe $500 with an interest rate of 7 over 2 years. Your new balance would be $572.45. All right, now there is another way of writing this program. What if we would like to allow the user to enter in values that are equal to 0, while principal is less than 0? If principal is less than 0, principal can't be less than 0. Let's do that for rate. Interest can't be less than 0. time. Time can't be less than 0. Here's what happens to our program. Remember that we're declaring our variables at the top. Nothing happens. We go straight to the results. So the reason that this is happening is that when we reach the while loops, this condition is false from the beginning. We never end up entering these while loops. We skip over them because these 3 conditions are all false. We can write a different variation of this while loop where we could say while true. True is a Boolean. That means this while loop will continue forever unless we explicitly break out of the while loop. We're going to add an else clause. Else, we will break. Break will break out of a loop. With our second while loop, change rate is less than 0 to while true. Then we will add an else clause. Else, break out of the loop. While true. Else, break out of the loop. We should be able to enter 0 values in now. Enter the principal amount, 0, 0, 0. Balance after 0 years is $0. This should work the same as before, but we should be allowed to enter in 0 values. $1,000. Interest rate of 0. After 1 year is still $1,000. Well, okay then everybody. I thought that would be an interesting project to create. Now that we know how while loops work, you could write either a standard while loop with a condition such as principal is less than or equal to 0, or you could say while true. This loop would continue forever. You would need to explicitly break out of the while loop using this break keyword, which we'll cover again in for loops. But yeah, that is a compound interest calculator in Python. Hey everybody, in this topic I need to explain for loops. A for loop will execute a block of code a fixed number of times. You can iterate over a range, a string, a sequence, anything that is considered iterable. I'll have more examples for you in future topics. There is a lot of overlap where you could use either a while loop or a for loop, but for loops tend to be better in situations where you have to do something only a fixed number of times. Here's an example. Suppose we need to count to 10. If we were to use a for loop, we could write something like this. We would type for, then we would need some sort of counter. Typically, you see people write x. For x in, then we will use the range function. What number would we like to start at? I would like to start at 1, then count to 10. But the second number is exclusive, so really we're going to write 11 if we want to count to 10. So then colon, then hit enter. Whatever code you would like to repeat a certain number of times, you will list underneath the for loop and make sure the code is indented too. I will print whatever our counter x is. When I run this code, we will begin at 1, then stop once we reach 11. So yeah, there we are. We have begun at 1, and we have counted all the way to 10. So that's the basic syntax for a for loop. For, some counter. Really, you can name this anything. Sometimes you'll see people name this as counter, and that would work too. But let's stick with x. In, some range. Where would we like to begin? Where do we stop? Okay, now let's count backwards. Let's start at 10, then count down to 0. When we escape the for loop, let's print Happy New Year. When we print Happy New Year, we are outside of the for loop. To count backwards, you can enclose your range function within the reversed function. Reversed. So we begin at 10, count down to 1, then print Happy New Year in this case. To count backwards, you would enclose the range function within the reversed function. There is an additional parameter too you could add. That is the step. If you would like to count by 2s, you would add comma 2. So I'm going to get rid of Happy New Year. Let's print the numbers 1 through 10, but we will count by 2s. And this does begin at 1 though. So 1, 3, 5, 7, 9. If you were to change the step to 3, you would count by 3s. Beginning at 1, 4, 7, 10. So the range function isn't the only thing you can iterate over. You can iterate over a string. Let's say we have a credit card number. Credit card equals, I'll make up some credit card number with dashes. That is good enough. For x in credit card, print x. X will hold our current position. At first it'll be 1, then 2, 3, 4, dash, so on and so forth. So here's our credit card number, 1, 2, 3, 4, dash, 5, 6, 7, 8. I think you get the idea. So you can iterate over a string with a for loop as well. We'll have a few projects involving that. There are 2 useful keywords as well. These aren't exclusive to for loops. You can use these within while loops as well. They are continue and break. Suppose we are going to count to 20. For x in range, we will begin at 1, stop at 21. I think this is kind of a dumb example, but it gets the point across. 13 is considered an unlucky number, right? What if our counter reaches 13? I would like to skip over it. Well, we can do that with the continue keyword. If x is equal to 13, we will continue and skip over that iteration. Else, we will print whatever our counter is. So let's take a look. Yeah, we have the numbers 1 through 20, but we have skipped the number 13. To skip over an iteration, you can use the continue keyword. Whereas the break keyword, we will break out of this loop entirely. If x is equal to 13, then break. So yeah, we have only counted to 12. Once we reach 13, we have escaped the loop. So yeah, everybody, those are for loops. You can execute a block of code a fixed number of times. You can iterate over a range, a string, a sequence, anything that is considered iterable. There is a lot of overlap where you could use either a while loop or a for loop. While loops tend to be better if you need to execute something possibly infinite amount of times, such as when you're accepting user input, for example. But yeah, everybody, those are for loops in Python. What is going on, everybody? In today's topic, we're going to be creating a countdown timer in Python. We'll be using what we learned in the previous topics. Let's begin. We'll need to import the time module. There's a pretty cool function within the time module. That is the sleep function. Type time.sleep, add a set of parentheses. Within the set of parentheses, our program will essentially sleep for a given amount of seconds, like 3. After 3 seconds, let's print something. This is just a demonstration. Time's up. When I execute this code, nothing happens for 3 seconds, but after 3 seconds passes, it displays our message, time's up. So you can use the sleep function of the time module to sleep for a given amount of time. We will ask the user, how long would they like to set the timer for? We will create a variable. Let's say my time. My time will be in seconds. We will create a prompt. Enter the time in seconds. Then we should typecast our input as an integer. We'll need to create a loop. We could use either a while loop or a for loop. There's a lot of overlap where you could use either one. I'll use a for loop in this case. For, we'll need some sort of counter. X in our range, 0 through my time. After each iteration, we will sleep for 1 second. Let's test what we have so far. I would like to sleep for 3 seconds. I think that's approximately 3. But now we are going to print whatever x is. Print x. X is our counter. 0, 1, 2. Time's up. We're getting somewhere. But I would like to count backwards. What we could do is enclose our range function within the reversed function. But another technique that we can use is by using a step. Let's replace 0 with my time, then end at 0. But we will set the step to be -1. Then we can increment backwards using this function. That's another technique too, to count backwards. So let's wait for 3 seconds. 3, 2, 1, time's up. Now let's display a digital clock of some sort. but we would have to calculate how many hours, minutes, and seconds there are. So let's calculate seconds. Seconds equals x is our counter, remember, modulus 60. Within our print statement, we'll use an f string. We are displaying hours, minutes, and seconds. I'll add some placeholders for each of these fields. We have seconds. With our digital clock, we can't go above 60 for either seconds or minutes. That's why I'm using modulus 60. The modulus operator gives you the remainder of any division. Let's begin at 11. So 11, 10, 9. So it is counting down, but I would like to add some zero padding. And we can do that with the format specifier. After seconds, I will add colon. I need to display 2 digits, then zero pad those digits. Let's try that again. I will wait for 11 seconds, 11, 10, 9. Yeah, and we do have some zero padding. So that's looking more and more like a digital clock. Let's add minutes then. So to calculate minutes, let's assign variable minutes equal to x divided by 60 because there's 60 seconds within a minute. But then I'm going to typecast the result as an integer. Modulus 60. We would not like this field of minutes to go above 60. So let's add a placeholder. We're displaying minutes. Format specifier 0, 2. Now I'm going to wait for 65 seconds. That is 1 minute and 5 seconds. Then I just want to be sure that we go below a minute. Yep, it's working. Then let's calculate hours. Oh, by the way, to stop your program from running, hit this red square up in the corner. Let's calculate hours. Hours equals x divided by 3,600. There's 3,600 seconds in an hour. Then we will typecast the result as an integer. Within our f string, we will display hours, format specifier 0, 2. Then I will run this program. Let's wait for 3,605 seconds. That is 1 hour and 5 seconds. And I just want to be sure that we go below 1 hour. Yeah, all right, so that works. So the reason that I didn't add modulus 24, I don't have days within my f string. We can display any amount of hours. I will exclude modulus 24. All right, everybody. Well, I thought that'd be some good practice with working with loops. We should try and do as many exercises as we can. And yeah, that is a countdown timer program in Python. Hey everybody, so I guess in today's topic, I'm going to be explaining nested loops, it looks like. So a nested loop, think of it as a loop found within the code of another loop. You have a loop, right? Any code within that loop is indented underneath that loop. Well, you could have a looping structure found within the code of another looping structure. The loop on the outside is the outer loop. The internal loop within the outer loop is known as the inner loop. Where you'll encounter nested loops, it's really situational. You could have a while loop inside of a while loop, a for loop inside of a for loop inside of a while loop inside of a for loop, etc. So here's a demonstration. Let's begin by displaying the numbers 1 through 9, but we'll use a loop. For x is our counter, in range 1, 10. Remember that the second number, in this case 10, that's exclusive. Then I will print our counter x. This program will print the numbers 1 through 9. Now we have an exercise at the end of this topic. I should probably explain this feature. So with a print statement, we end each print statement with a new line character. If I need all of these numbers on the same line, at the end of my print statement, I can add comma, end equals an empty string. Normally with a print statement, each ends with a new line character, but we can set that to be something else. So when I run this again, all of these numbers are on the same line. Or you could add a different symbol, like dash or a space. Each of these characters is now separated with a space. But let's stick with an empty string. Okay, so we have used a loop to count the numbers 1 through 9. What if I would like to repeat this 3 times? Well, I could create another loop. For x in range, you could say 1 comma 4, or you could just say 3, either way. Whatever code is within this loop will be executed 3 times. Let's cut our original for loop, then place it within the code of our new loop. Our outer loop will have this code repeat entirely 3 separate times. But we do have one thing we need to pay attention to. We have 2 counters with the same name. You'll want to be sure that they're different. Let's rename the counter of the inner loop to be y instead of x. And be sure to change that here as well. Now, when I run this code, we're completing, let's see, 27 iterations. To exit this for loop, we need to count the numbers 1 through 9. Once we do so, that is 1 iteration of the outer loop. But our outer loop is saying, hey, we still need 3 total iterations. Now, if you would like these on separate lines, let's make this look a little different. Let's add each iteration of the outer loop onto a new line. So within the outer loop, but not within the inner loop, I'm going to create just a blank print statement. This will just print a new line. Let's try this again. With the inner loop, we count the numbers 1 through 9. After we exit the for loop, we will print a new line, then repeat this all over again until our outer loop is satisfied. So that's basically a nested loop. It's just a loop that's inside of another looping structure. So let's create a project. We're going to print a rectangle made of some symbol that we set. We'll have the user type in how many rows and columns this rectangle will have. We'll reuse this code that we have already written. So this time, let's accept some user input. Rows equals input. Enter the number of rows. Then we should typecast this input as an integer. Let's copy this line, paste it, change rows to columns for the second line, enter the number of columns. Then let's create a symbol. Symbol equals input. Enter a symbol to use. We already have this rectangle structure, right? Think of it as the outer loop is in charge of the rows. Let's change in range 3 to in range rows. The inner loop will be in charge of the columns. For y in range columns, we will print our symbol, whatever the user chooses. So let's try this again. Enter the number of rows. How about 4 rows, 10 columns? I'll use a $sign. So here's our rectangle. We have 4 rows, then 10 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's try it one more time. 3 rows, 5 columns, and I'll use an asterisk. Yep, 3 rows, 5 columns. So yeah, that's a nested loop. Really, it's just a loop that's inside of another loop. The type of loop really doesn't matter, as well as what's within each loop. It's just a situation where you have a loop inside of another loop. And yeah, those are nested loops in Python. Well, hello everybody. Today I will be explaining a few different types of collections in Python. There's 4 general purpose collections. 3 of them are lists, sets, and tuples. There are also dictionaries, but I'll save that for the next topic because they can be kind of tricky. A collection, I would think of them as a single variable, and I'm saying that within quotes, that is used to store multiple values. That's how I would explain a collection to a beginner. For example, let's say we have a variable. Variable fruit. Fruit equals some value, like apple. And then I can print this fruit, which is apple. I could turn this variable into a collection by surrounding my values with either a set of square brackets for a list, curly braces for a set, or parentheses for a tuple. Let's begin with the list. If I would like to store more than one value in this variable, I will surround my values with a set of square brackets. This variable is now a list. I can store multiple values separated with a comma. Not only do we have an apple in this variable, but we have an orange, a banana, and coconut. One naming convention that I like to use If I declare a collection, such as a list, set, or tuple, I like to take the variable name and make it plural, just so that it's more obvious that this is a collection of values. Technically, in the English language, fruit would still be plural. English is a weird language. We now have a list of fruit named fruits. If I were to print my list, this is the result. We have all of our values enclosed with a set of square brackets. To access one of these elements found within your list, you can use the index operator, much like what we can do with strings. The first element would have an index of 0. That would print my value apple. Index of 1 would be my orange. 2 is banana. 3, coconut. What about 4? We don't have a value there. List index out of range. Each value in a collection is also known as an element. If we attempt to access an element that's not found within our collection, you'll run into an index error. With the index operator, you could set a beginning index, an ending index, and a step. I would like the first 3 elements. You could say 0, 3. That would give me apple, orange, banana. Technically, you don't even need the 0. You need that colon, though. We can even use a step. I would like every second element. Apple, banana. It's every second element beginning from index 0. Maybe I would like my fruit backwards. I'll set the step to be -1. Coconut, banana, orange, apple. You can use the index operator with collections, much like you can use with strings. Another cool thing you can do too with collections is that you can iterate over them with the for loop. For x in my collection, fruits. What would we like to do? I will print whatever x is. So we have iterated over our list. Apple, orange, banana, coconut. Now x isn't really too descriptive. What you'll see some people do is that with their collection name, it's plural. Their counter will be the singular version of that word. If our collection name is fruits, let's rename x as fruit, singular. It's not mandatory, but that's a common convention. It's more readable that way. For every fruit in fruits. If this were cars, you could say for car in cars. Our counter is storing whatever value is within our collection. So what are all the different methods that we can use with collections? To list the different methods that are available to a collection, you can use the dir function. Within this function, add your collection, fruits. But we would need to print this. Let's surround this function with a print statement. These are all in alphabetical order. We have attributes, which I have not explained yet, but I will in a future topic. But if we scroll to the end, we have a bunch of different methods that this list can perform. Append, clear, copy, count, extend, index, insert, pop, remove, reverse, and sort. If you would like a description of each of these methods, there is a help function. Help, add your collection to the parentheses, then we would need to print this. Here's a description of all the methods and attributes. For example, we have our sort method. And here's a description. Sort the list in ascending order and return none. And then a bunch of other stuff. If you ever forget what you're capable of with a list or other collection, you can always use the help function to print a description of the attributes and methods available. If you need the length of how many elements are within a collection, there is the length function. Return the length of my list fruits, then let's print it. There's 4 elements within my list. The length function returns 4. If I were to add an extra element, like a pineapple, then that number would be 5. Let's remove that. Using the in operator, we can find if a value is within a collection. Is our value apple in fruits? But then we would need to print this. This operator will return a Boolean, so let's print whatever that is. Is apple in fruits? That is true. But is pineapple? Pineapple is not. It's false. You can use the in operator to find if a value is within a list, and that applies for your other collections too. With lists, they're ordered and changeable. Duplicates are okay. We can change one of these values after we create our list. let's take fruits at index of 0. I will set this equal to be a pineapple. Then let's iterate over our fruit using a for loop. Okay, the first element is no longer an apple, it's a pineapple, then orange, banana, coconut. Using an index, you can reassign one of the values. If I were to change 0 to 1, well, now we have an apple, pineapple, banana, coconut. Let's cover some of the methods that are found within a list. We can append an element. Type the name of the list, dot, append. What would we like to append to the end of this list? Let's append a pineapple. I'm going to get rid of this for loop. I'm just going to display my list. There, we have an apple, an orange, banana, coconut, pineapple. To add an element to the end of a list, use the append method. To remove an element, you can use the remove method. Fruits.remove. Let's remove our apple. Our apple is no longer there. We have an orange, banana, coconut. Using the insert method, we can insert a value at a given index. Fruits.insert. List an index. 0 would be the beginning, then a value. Pineapple. Now we have a pineapple, apple, orange, banana, coconut. The sort method will sort a list. Fruits.sort. These are all in alphabetical order now. Apple, banana, coconut, orange. To reverse a list, you would use the reverse method. Fruits.reverse. Coconut, banana, orange, apple. However, these are not in reverse alphabetical order. These elements are reversed based on the order in which we place them. If you would like reverse alphabetical order, you can first sort and then reverse. Now we have orange, coconut, banana, apple. To clear a list, use the clear method. Fruits.clear. All of the elements are gone. We can return the index of a value. Let's return the index of apple. Fruits.index, list an element. Then we will need to print this. Let's print the index that is returned. The index of apple is 0. Coconut, that would be 3. What if we don't find a value, like a pineapple? Well, we have an error. Pineapple is not in list. You could count the amount of times that a value is found within a list, because duplicates are okay. Fruits.count. Let's count how many bananas are in this list. Banana. Then print it. 1 banana is found within this list. How about pineapples? There are 0. Now, those are lists. Surround your values with a set of square brackets. These values are ordered and changeable. Duplicates are okay. Now let's talk about the next collection, which is a set. To create a set, surround your values instead with a set of curly braces. Our collection of fruits is now a set. A set has different benefits. The values are unordered and immutable, meaning we can't alter these values. However, we can add and remove elements. A set does not include any duplicates. I'm going to delete these methods, then print fruits. We have all of the same values, but they're not in the same order as they were originally. A set is unordered. If I were to run this again, they will likely be in a different order. See, now we have a banana, apple, coconut, orange. To display all of the different attributes and methods of a set, you can use the dir function. And here's all of them. Some of these methods are a little more advanced, but there's a few we might recognize, like add, clear, copy. For an in-depth description of these methods, you can use the help function. Much like what we did before. To find the length of our set, we can use the length function, which is 4. We can use the in operator to find if a value is found within this set. Unfortunately, pineapples are not within our set. Now, if I was to use the index operator of my set, this is what would happen. We have an error. Set object is not subscriptable. We're not able to use indexing on a set because they're unordered, much like what we can do with a list or a string. We can't change the values of a set, but we could add or remove elements. Let's use the add method to add, guess what, a pineapple. That is okay. Orange, apple, pineapple, coconut, banana. We can remove an element, fruits.remove. Let's remove our apple. Our apple is gone, coconut, orange, banana. We can pop. The pop method will remove whatever element is first, but it's going to be random though. Orange, coconut, banana. Apple, coconut, banana. Apple, banana, coconut. You can clear, fruits.clear. The elements of our set are gone. Those are a few of the more useful methods for beginners. As a summary, a set is a collection that is unordered and immutable. You can't change the values, but adding and removing elements is okay. No duplicates are allowed. Let's try that real quick. I'm going to add a second coconut. Yeah, see, we only still have one coconut. Sets may work well if you're working with constants. Maybe colors, for example. You need to find if a color is within a set. Alright, now lastly, let's talk about tuples. A tuple is a collection that is surrounded with a set of parentheses. Tuples are ordered and unchangeable. Duplicates are okay. One benefit of a tuple over a list is that tuples are faster than lists. If you're working with a collection, and it's okay if the collection is ordered and unchangeable, you might as well use a tuple because it's faster. When I print our tuple, all of these values are surrounded with a set of parentheses. Again, we have the dir function to display the attributes and methods. There's not as many for a tuple for methods. We only have count and index. Again, there's also help to display a description of these attributes and methods. You can find the length of a tuple with the length function. We have 5 elements within here. Using the in operator, we can find if a value is found within our tuple. Our pineapple is not within our fruits. So there's only 2 methods we have access to. Let's find the index of apple. Fruits.index apple. Then I will print whatever is returned. Apple is found at index 0. There's also count. Fruits.count. How many coconuts are found within our tuple fruits? Count the coconuts. Then print this. How many coconuts? We have 2 coconuts. And then again, with any of these collections, they're iterable, so you can iterate over them using a for loop. For fruit in fruits. Yep, apple, orange, banana, coconut, coconut. All right, everybody, so those are collections. Think of them as a single variable used to store multiple values. There's 4 general purpose collections for beginners: lists, sets, tuples, and then dictionaries, which we'll talk about next. Each of them has unique benefits. Lists are ordered and changeable. Duplicates are okay. A set is unordered and immutable, but adding and removing elements is okay. No duplicates allowed. A tuple is ordered and unchangeable. Duplicates are okay, and they are faster than lists. Use tuples if you can over a list. But yeah, those are a few collections in Python. Hello everybody. Today we will be creating a shopping cart program. This program will be an exercise to follow the previous lesson on lists, sets, and tuples. The more that we practice with those collections, the better we'll be at using them. So I thought we'd create an exercise to get the hang of it before moving on. In this program, we will have 2 lists. Foods. These lists will be empty. We'll declare them but not use them quite yet. And prices. Then a total. Total equals 0. The reason that I'm not using tuples is that tuples are unchangeable. We're going to ask a user what food they would like to buy. We can't append any elements to a tuple. We're not using sets because sets are unordered. I mean, I guess technically you could, but at the end of this program, I'm going to print our shopping cart in order. So I think lists would probably be the best. We have an empty list of foods and an empty list of prices. We'll use a while loop. While true, if our condition is set to true, we'll need some way to break out of the while loop. we'll need a break statement somewhere. We'll get to that later. We will ask the user what food would they like to buy. Let's declare variable food equal to input, enter a food to buy. To exit the while loop, you need to press Q. Q to quit. Then let's check if food is equal to Q, lowercase q, then we will break. We're not done with the program, but let's at least test it. Pizza, hamburger, hot dog, Q to quit. Okay, it looks like it works. Now what if somebody types in uppercase Q? Pizza, hamburger, uppercase Q. Well, we can't actually quit. After accepting our user input, if food.lower method, this will take our input, make it lowercase, just for a comparison. Let's try that again. Pizza, hamburger. I'll type capital Q to quit, and that is valid. Follow food with the lower method to temporarily make the user input lowercase, just in case they type in capital Q. If the user doesn't want to quit, let's add an else statement. Else, let's take our foods, use the append method, then add whatever food the user typed in. We'll also need a price. Let's ask a user for the price. Price equals input, enter the price of, let's use an F string, a whatever food the user types in. Pick a unit of currency. I'll pick dollars. We are working with numbers. We should typecast our input as a floating point number, since we're working with prices. So we will accept a price, add our food item to our list of foods, do the same thing with prices. Prices.append whatever the price was. And that is the while loop. Let's test this program again to be sure that everything's working. Pizza. Pizza will be $5.99. Enter a food to buy. Hamburger. Hamburgers will be $3.50. Hot dog. Hot dogs will be $1.75. I would like to quit. I will type either capital Q or lowercase q. Both will work. And we have escaped the while loop. So the while loop is now complete. Outside of the while loop, let's display our shopping cart. Let's print some decorative text. Maybe 5 dashes. Your cart. Then another 5 dashes. I will then iterate over all of the elements found within my foods list. For every food in my list of foods, let's print each food item. Let's take a look so far. Again, we have a pizza. The price was $5.99. Hamburger. The price was $3.50. Hot dog, $1.75. Q to quit. Okay, your cart. That will display the individual list items. If you would rather have these list items arranged horizontally in one line, you can add this keyword, end equals. This end keyword will replace the new line character at the end of a print statement with some other character like a space. Let's try that again. I'll try not to take too much time. Pizza, $5.99. Hamburger, $3.50. Hot dog, $1.75. Q to quit. Yeah, that's much better. We are horizontally listing all of the different items within our list. You could revert back to the vertical list if you'd prefer that. I'll keep my output like this. Then we will need to iterate and add up all the prices. For every price in prices, we do have a total variable that we declared. Let's utilize that. Total equals total plus price. Otherwise, we could shorten this to plus equals price. That would do the same thing. Then we will display the total. Print, I'll use an F string. Your total is I'll add a unit of currency. I picked the $sign, whatever the total is. Okay, let's run this program one last time. Enter a food to buy. Pizza, which was $5.99. Hamburger, which was $3.50. Hot dogs, they are $1.75. Queue to quit. Here's your shopping cart. I'm just going to add one new line real quick, right before we display the total. Just an empty print statement. Here are the results. Your cart, pizza, hamburger, hot dog. Your total is $11.24. All right, everybody. Well, that is a shopping cart program. I thought this would be a fun exercise to follow the previous lesson on lists, sets, and tuples. And well, yeah, that is a shopping cart program in Python. Hey, what's going on, everybody? So today I'm going to be explaining 2D lists. 2D meaning two-dimensional. You do also have the capability of creating 2D tuples. I thought today we would use 2D lists just because they're pretty flexible. A two-dimensional list is just a list made up of lists. It's really useful if you ever need a grid or matrix of data, kind of like an Excel spreadsheet. Let's create 3 lists. A list of fruit, vegetables, and meat. I'm going to speed up this video. Feel free to pause if you need to catch up. Here I have 3 lists, a list of fruit, vegetables, and meat. Each of these lists is a one-dimensional list. To create a two-dimensional list, well, you would begin by creating a one-dimensional list. Let's create a list of groceries. All I would need to do is add my individual lists as elements to the outer list, the 2D list. We have fruits, vegetables, and meats. Normally, to print a list, or your other collections, you would print the name of the list. In my list fruits, I have apple, orange, banana, coconut. To access or change one of the elements, you would type the name of the list, then use the index operator. So fruits at index of 0 is a pineapple again. With a 2D list, it's a little different. If I were to print my 2D list of groceries, we would lay out the entire 2D list flat. We have individual lists separated with a comma, all enclosed within a set of square brackets. Taking the elements found within our 2D list, I'm going to line these up kind of like this. It kind of represents a grid or matrix with rows and columns. Each individual list resembles a row. Each element resembles a column. If I were to print groceries at index 0, in place of returning one element found within one of the lists, that would return an entire row. So groceries at index 0 is my fruits list. Groceries at index 1 is my vegetables list. Groceries at index 2 is my meats list. For one of the elements found within one of the rows, you would need 2 indices. If I need the apple from the first row within my 2D list of groceries, that would be row 0, column 0. It's kind of like coordinates. Row 0, column 0, that would be my apple. 0, 1, which is an orange. 0, 2 is banana. 0, 3 is coconut. For the next row, I would set the first index to be 1. Row 1, column 0, that would be celery. I'm going to speed run this real quick just to show you all the different elements. 1, 1 is carrots. 1, 2 is potatoes. If we try to access 1, 3, that index is out of range because we only have 3 elements within this row. So then the next row would have an index of 2. Column 0 would be chicken. 2, 1 is fish. 2, 2 is turkey. 2, 3 is out of bounds. To access an element from a 2D list, you would need 2 indices in place of 1, because using just 1 would return the entire row, like so. Now, when you declare a 2D list, you don't need to necessarily give each inner list a name. We could do something like this. I'm going to replace these names with the rows. I'm just going to put these on a new line to make it more readable. There, that would work too. Just separate each inner list with a comma, then enclose everything with a set of square brackets. If you ever need to iterate over the elements of a 2D list, you can use nested loops. If I were to use a single for loop, let's say for every, maybe collection. For every collection in groceries, let's print what our collection is. Using a single for loop would iterate over the rows, but to also iterate over the elements found within each row, we would use a nested loop. For every food in our collection, let's print what our food is. Using nested loops, we can iterate over all of the elements found within our 2D list. But I'm going to make this more organized, like that grid structure we have. I'm going to replace the new line character at the end of a print statement with a space. Then, when we exit the nested loop, I will print a new line by using just an empty print statement. There, that kind of resembles our grid structure. We have rows, and we have columns. With two-dimensional collections, you're not limited to just lists. You could create a list of tuples, so the inner rows will be surrounded with a set of parentheses. You know, this is also valid too. Or you could make a 2D tuple. It's a tuple that's made up of tuples. You could make a tuple made up of sets. Sets are enclosed with a set of curly braces. Here we have a tuple made of sets. Use whatever is best for your own programs. Let's go over an exercise. Let's create a two-dimensional keypad that you would normally find on a phone. We have three data types: a list, a set, or a tuple. The elements in a set are unordered, so we can't use that. These numbers need to be in order. If we have the option, a tuple is faster than a list. A tuple is ordered and unchangeable, so we should use it if we can. And that's perfectly fine. Let's create a 2D tuple this time. I will name this 2D tuple numpad. We have an outer set of parentheses, then an inner set of parentheses for each row. We will have 4 rows. The first row will be 1, 2, 3. The second row, I'm going to put this on a new line, 4, 5, 6. The next row will be 7, 8, 9. Then the last row will be an asterisk character, then 0, then the pound sign. So numpad, in this case, is a 2D tuple. Let's use a for loop to iterate over every row. This will be the outer loop. For every, maybe row. For every row in numpad, let's begin by printing our row. So we're printing every row in our numpad, but I'd like to remove the parentheses. Let's create a nested loop for every, maybe num. For num in row. Print whatever that num is. We have one long vertical line. Let's replace the new line character at the end of our print statement with a space. Then when we escape the nested loop, let's print a new line. And there is our telephone number pad. You can see it's a grid made up of rows and columns. So yeah, that's a 2D list. Well, a 2D collection. It's a collection that's made up of collections. Then with our numpad, we made a 2D tuple. If you ever need a grid or matrix of data, a 2D collection would work perfect. And there you have it, everybody. Those are 2D collections in Python. Hello again, everybody. So today we're going to create a quiz game in Python. Let's declare all of the different collections and variables that we'll need first. We will need a tuple of questions, a 2D tuple of options. My quiz will have 5 questions, but you can add more or less questions. Then a tuple of answers, a list of guesses. We will be appending guesses to our list. That's why we're using a list rather than a tuple. A score variable, which I will set to be 0. Then question number. This variable will keep track of what number question we're on. All right, let's begin with our questions. I have 5. Here are my questions. They're all science related. Feel free to choose your own. This is what I have. How many elements are in the periodic table? Which animal lays the largest eggs? What is the most abundant gas in Earth's atmosphere? How many bones are in the human body? Which planet in the solar system is the hottest? These are the questions, but we'll need options. Let's add 4 options for every question. That's why we're using a 2-dimensional tuple. Each inner tuple will consist of 4 elements. They will be options A, B, C, or D. Let's copy these elements, then paste them within each tuple. This first element corresponds to my first question. How many elements are in the periodic table? I'll come up with some answers. I'll add some answers for the rest of these tuples too. We have a tuple of correct answers. The orders are C, D, A, B. If you come up with your own options, your answers may be different. Now that we have all of our different collections and variables taken care of, let's display each question. I will iterate over our tuple of questions. They are iterable. For every question, in questions, I'm going to print some decorative text. I think that's probably good. Then I will print each question we're iterating over. So let's see what we have so far. There's all 5 questions. After we display every question, I need to display every option. For every option in options. Our options is a 2D tuple. Let's add the index operator. The index is going to be our question number variable. It's a number. So at first, we're accessing options at index of 0, then 1, 2, 3, 4, 5. We will print every option in options at a given row number. Let's test this. Okay, we have some options, but all of these options are for the first question. We will need to increment our question number. So let's do that maybe here. Question number plus equals 1. That is much better. Before iterating the question number, we will ask the user for a guess. Guess equals input, enter A, B, C, D. In case the user types in something that's lowercase, I will follow this input with the upper method to make the user input uppercase. we will take our list of guesses, use the append method, add our guess to that list. If our guess